So in lab this week, we're going to be dealing with various different concentration units. So we're going to be dealing with molarity, which we're familiar with, right, which is moles of solute per liter of solution. And then a couple new units that we haven't really used that much in lab. The first one is percent by weight. So we can call that percent W divided by W. So that's weight by weight. And that can be defined as the number of grams of solute per 100 grams of solution. Okay. And then we can also talk about weight, percent by volume, which would be weight divided by volume. And that's grams of solute per 100 milliliters of solution. So notice the only difference here is the bottom unit, right, which is our either mass or volume. So I want to look at an example of how we convert between these. So let's say we have something that is 15% by weight, so weight of sodium chloride, and that's aqueous solution, so it's in water. And so what we want to do is we want to find out what is the percent by volume and what is the molarity. Okay, so let's look at the first conversion there. So if we have 15% weight, we can rephrase this or rewrite it like we have over here. So that would be 15 grams of our solute, sodium chloride, per 100 grams of solution. Now notice if we want to convert between weight and weight volume, we just need to figure out the volume that would correspond to our 100 grams. So what do we need? Well, to go between these two, we need density. Right? We need the density of our solution to go from grams to volumes, right? Mass to volume. Well, if we were to look up the density of this solution, we would notice that it's 1.15 grams per milliliter. So that would be a way that we can convert 1.15 grams of solution per 1 milliliter of solution. Okay, and so now what we've done is we've converted grams to milliliters. And this is going to give us now grams of sodium chloride to milliliters of solution, which would be our weight by volume. And so we would end up getting 17.2 grams NaCl per 100 milliliters of solution, which would be 17.2 weight volume percent sodium chloride. Okay. So to go between these two, we need to know the density. If we don't know the density, there's no way to relate those two. Okay. So we went ahead and we talked about converting between weight and weight volume. Now let's go ahead and convert to molarity. So we want to convert from this idea of our weight to weight volume. Okay. So let's start with what we know, right? Our 16 grams of sodium chloride per 100 grams of solution. Well, again, we need to get to a volume unit of our solution. So we would first want to convert, just like we did here, from our mass to volume. Okay, and then we would also notice that what we want to get to is the milliliters to liters. So then we just need to do one more conversion. That's going to convert our milliliters. So 1 milliliter is 10 to the negative 3 liters, right? That's what milli means. Okay, and so now we would get from milliliters to liters of solution. Okay. Well, the last step that we want to do is we want to convert our mass, right? We need mass of sodium chloride to moles of sodium chloride. Well, if we're going to do that, we can just use the molar mass of sodium chloride, okay? And the molar mass of sodium chloride would be 58.44 grams sodium chloride per mole of sodium chloride. And so now we see we're left with units of moles of NaCl, which is our solute, per liter of solution. So once we go ahead and we finish out this calculation, we notice that we're going to get 2.95 moles of NaCl per liter of solution, which is the definition of molarity, right? So that would be 2.95 molarity NaCl. Okay. Now, one thing I want to really emphasize in these relationships is we got to keep track of the mass of what this grams means versus this grams. So you notice I always wrote out not just grams per gram, I wrote out grams of my solute per gram of solution, or this relationship grams of NaCl per mole, or grams of solution to milliliters of solution. So I always wrote out what those corresponded to. If we don't do that, we're going to get lost in these different pieces and these different calculations. And we're going to mix up, well, maybe I used the density incorrectly, and I didn't think about it's the mass of the solution. I thought it was the mass of my solute or something. Okay, so we really want to keep track of these as you are working through these calculations as you prepare for lab this next week.